Okay, so basically this is your lab class. I will start the lab, but I will start this lab I will show you. But basically before starting the lab, the discussion which we are doing, that discussion I will complete, and after that I will start the lab. Okay, so the discussion which we are going on, that is the segmentation concept that we are discussing there. So basically what it is, here the segmentation is basically the memory management scheme. The segmentation is basically the memory management scheme that supports the user view of memory. That supports the user view of memory. And here the logical address space is what? The logical address space is the collection of the segments, and each segment contain a name and length, and each address specify both the segment name and the offset. So here in segmentation, what we are doing, in the segmentation we are doing particularly, we are mapping a two-dimensional user defined address into one-dimensional physical address. So basically the thing which we are doing is mapping a two-dimensional address, two-dimensional user defined address into the one-dimensional physical memory. And here you see the logical address. The logical address basically consists of the segment number, which we have already said that a logical address contains the segment number and the offset. So segment number, it is what? It is used as an index number into the segment table. It is used as the index number into the segment table. And offset is what? The offset, it will be must between 0 and the limit. Otherwise, the logical address attempts beyond the physical memory segment. So basically how it looks like, you see, it looks like this. So this is the block diagram. Now in this block diagram, if we describe, then CPU is what? CPU is generating the logical address. We know that CPU always generate the logical address. So that means CPU will generate the logical address. Now this logical address will what? This logical address will be contained by the content, segment name and offset. This segment name will be as a index of the segment table. This is what a segment table is present. In this table, the index will be this segment name. This segment will be the index of this segmentation table. This table contains limit and base. So this limit is what? This limit is checked. That what we have already said, that offset is what? Offset, it is the range between 0 and the limit. So this limit it is. So 0 and between this limit. In the segmentation table, the limit is there, that limit. Between this, it will be checked. So if it is yes, then with combining the base address, it will go to the address will be the physical address. It will create, and this will be in the physical memory. If it is no, then it will go again in the our logical address. So this is what the segmentation block diagram. Now, the next question that might came, what is the explanation of the Billardis anomaly? The next thing that comes is the explanation of the Billardis anomaly. So, what is Billardis anomaly means? Billardis anomaly state that it is possible to have more page fault. It can possible to have the more number of page fault when the increasing number of page frame while using the FIFO method of the frame management. So if the number of page frame increases, then the anomaly states more page fault will happen. Now you remember when in the our locality time I have discussed that we can use this technique using FIFO, LRU, least recently used first in first out technique. Now here, depending upon what? Depending upon the page frame. If the page frame, increasing number of page frame exists, then what? The page fault have more page fault. It is possible that more page fault has been what? More page fault when increasing the number of page frame. So page fault, because it we have seen that yes, this page is available. Okay, so that means what? We have, let's say, 1, 2, 3, 4, 5, and the frame is what? In this frame. So this is what these blocks we should have to position, and here is our frame. So this is frame, so that means, and this frame length is what? This frame length is 3. So this frame length is 3 means at first time 1 is there. So let's say after that again 1, again 2. So first 1 will be there, then 2 will here, then 3 will here. This 3 is what? This 3 is the length of the frame. So at first 1, yes, 1 is available there. No, 1 is storing at the first time. So page fault. This is the fault. Then this is also a fault. This is also a fault. Now after 3, the number of already we have, this is fulfilled. So where we will place the 4? Now first in first out technique. So that means first in, what the first has in, 1 has first came. So in place of 1, we will replace the 1 with 4. Then after that, where 5 will be stored, there the 5 will be stored. Then again, let's say our 1 came. So where we will replace the 1? First in first out. So 3 has came first before 4 and 5. So here we will replace 1. So after then, among 4, 5 and 1, whom came first? 4 came first. So in this 4 place, we will replace 2. Then after there, let's say this can be 5. This is 1. So that means what? Next is 5, it is coming. So already 5 is present here. So that means heat. This is what? This is heat. Then next 1 came. 1 is also present there. So heat, you see. But if the Billardis anomaly problem comes, that more page fault will be possible when the number of page frame we increase. The number of page frame, if we increase, then the problem can be occurred in the FIFO method. And this is the FIFO method of the frame management. This problem can occur. So this problem basically, Billardis anomaly came of the FIFO technique. In the LRU technique, this problem, it is not suffered by this problem. LRU technique, this problem doesn't happen. Okay. So this is what? This is the Billardis anomaly. Okay. Clear till now?
Yes.
Okay. So next, in the next class, I will discuss about the our this paging technique, that how the paging technique works. Then the TLB buffer technique, how it works. I will discuss in the next class. So now in this class, this is a lab. So basically in the lab section, we have already seen about our half adder, that how the half adder can be made, then how the full adder can be made, Then we have already seen the half subtractor, full subtractor, then encoder, decoder, multiplexer, demultiplexer, all we have already seen. Now today we will see the construction of a 2-bit ALU, arithmetical logic unit, arithmetic logical unit. So ALU construction we will see. Logic unit, arithmetic logic unit, will construction of it we will see today. Now basically for doing that already, when we have performed all this using the Multisim software, but for doing this ALU, then we will see the universal shift register concept. All of this, if we have to perform, we have to perform it into another simulator. We have to perform this into another simulator, and that simulator name is what? That simulator name is Logisim. 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 So this is basically a simulator. So I will show you first that how this simulator can be installed in the system. So basically, I will show you. So everyone follow this, that you have to install, how you have to install the Logisim software. So basically first open the here, open your search engine, and there you write, it will be Logisim. So download Logisim, you will write, and from here choose the first one, that is source forge.net. In there you choose the Logisim download, and from here you download that. Okay, so basically one thing, that this, after this software you downloaded, it is very small because this is a simulator, so its length is not so big. You can download now. This is only 6.56 MB file. It is not so much thing, so much hardware is there, so much amount is there for storage. You can download, but one thing you should have to keep in mind, that the Java GRE should be installed, because if GRE is not installed, then you will not open it. So I will request everyone, so first download this Logisim software. This Logisim software, when you will download, you will see what there will be, the exe file will be there, but when you try to open that, if in your system the GRE is not installed, then it will not open. So for in that case, what you have to do, you have to download the GRE and install the GRE. After that, like how in the Java I have shown, that first you have to copy the path, path you have to copy in the by environmental variables, open in the environmental variables, and there you have to copy that. So like the Java we have already seen, in that Java you should have to install, and after installation it will be what, this will be down, you can able to open that. Okay, so everyone, first I will say that first you should download it, you should download. So is everyone's in system GRE JDK installed? Java is installed in your system?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
If Java is installed, then there will be no problem. You directly download that and it will be opened. Download this first, and very small size of file.
Yes, sir. It opened.
Yes, if there is not Java is there, then it will not open. In that case, you have to first install the JDK and GRE. Otherwise, it will not open. So let's start the program. So in my system, it has already installed. So I will open it. 1 minute. Okay, so after opening, everyone is seeing like this. When you open this, it is showing like that. A simulator, it is showing like that. So in this, using this simulator, we will design the 2-bit ALU. Today we will design the 2-bit ALU. So first, for designing the 2-bit ALU, the number of gates we required. The number of gates will be required: 2 AND gate, 2 OR gate, 2 XOR gate, 2 NAND gate, sorry, not NAND gate, NOT gate, and there will be the 2 multiplexer there should be used. So first, here you see in the left side there is mentioning main, wiring, gates, plexers, arithmetic, memory, input, output, and base. So from the gates which you required, from choose here. The first gate which we require, AND gate. So click on that AND gate and you will see like this. You will see like this. So here the AND gate which will be required, in the number of inputs of that AND gate will be what? The number of inputs of that AND gate will be 2 input. So from here we will choose the number of inputs as 2, and the size we want that it will be narrow, that means small. So you see, first a AND gate we have used, then after the AND gate we require an OR gate. Same as that, for OR gate also 2 input OR gate we require. So click as a 2, and from here choose narrow. So like this, the OR gate. Then XOR gate we require. So choose the XOR gate. Here also narrow, and number of inputs, that is 2. Okay. Same, after that we require a NOT gate. Okay. So same as that, we have to do what? Now we require a multiplexer. So here you will see plexers, it is written, that means inside of it there is the multiplexer. So here choose the multiplexer option and selection bit you choose as 2. The selection bit will be 2. Then another multiplexer also be required. The selection bit will be 2, because there will be another connection also. So we perform that. Now from here AND gate, then OR gate, then XOR gate, then NOT gate. Okay. So now choose like this. Choose as the east and data bits as 1. Okay. Sorry. Like this, you will choose here also. Choose this. Then after that, make the connection. And connect with it. So like this same connection we have to make. Go there inside it and change the data bit as the 2 bits. Okay. So total connection is made. Now we will check. When the bits will be there. So here this option you have to choose change values within circuit. So this will be placed, and at first let's say this bit is 1, this bit is 1 also, and in each cases this will be 1. So you see this upper 2 Okay, so first change the levels. So this will be, we are naming it as the, let's first we name this, so press over that and give the name as, let's say, A0. Then press over that and we'll give it as the name B0. Then for this we are giving a name as A1. We are giving it as the name B1. The name of it as the select bits. Its name we are giving as F1. Okay, so in the next class, because time is very less, so in the next class we again start from this. Okay, so this is the connection. This is the connection we have made. So in the